in this lesson, we're going to be focusing on how to balance the nuclear decay equations. So from radioactive decay in last lesson, we're going to take that and we're just going to do some sample problems where we balance them. So before we get started, remember the three main types of decay, or three main symbols. And actually, let me use a different color this time. I'll use red. Let me use red. Okay, so remember you first had alpha, which is the 4, 2, and there's an alpha sign, or since this is same thing as helium, we also write the 4, 2 helium. That's also fine use. That's for alpha. And then beta, we had the 0, -1, E. Beta has a symbol of this. I don't think I showed this before, but that's a symbol for beta. And then gamma was just this. And I like to put a 0, 0 here, just to let people know that nothing really happens to the reaction. As in, the product will look the same as the reactant, but this little gamma is actually a lot of energy. So this first example problem right here is actually for uranium. So it says uranium that's got an atomic mass of 235 and atomic number of 92. So uranium becomes thorium, which has a mass of 231 and a atomic number of 90. So you can see what happened here is that the mass number went from 235 to 231, so it went down 4, and this atomic number 92 became 90, so uranium became thorium, and so there's -2 there. So what happened to balance this out? Again, we can see that which of these would fit in the best would be the alpha. So you can either put this 4,2 alpha or 4,2 helium. This time I'm going to put a 4,2 helium on here. So let's see, 4,2. Actually, let me do the alpha instead. It doesn't matter, but just for fun. So that's really all you have to do is just see what fits the best in any questions you have. And I'm also going to do this one right here. Let me actually pull this down. Whoops. I'll do this right over here. It says protactinium 231 emits an alpha and a gamma. So now it's asking for two things. So I'm actually going to show you. This is going to be a little longer. So first things first, let's look at the periodic table. Where is protactinium? If you actually look at it, it's actually this one right here. It is got an atomic number of 91, and we use the mass of 231 that's given right there. So atomic number of 91, and the symbol is Pa. So let's do this right here. Whoops. Dismiss. Alright. So it's got an atomic number of 91, Pa, a mass of 231. So remember, it emits an alpha. So first we gotta get rid of an alpha, and then we're gonna do a gamma. So first thing's gonna happen is gonna be an alpha. So let's see, 4, 2, and I'll do the alpha. And then remember, all we're doing is taking out 4 from the top. 231 minus 4 is equal to, it's going to be plus, you have 227. And then this 91 minus 2 is going to be 89. Remember, as soon as we lose 2 protons, the symbol changes. So actually, that 89 is, let's see, where is this? It's actinium, which is AC. AC. And it also says it releases a gamma. So what you can do is you can put that little, remember, if something releases gamma, it already has a lot of energy. So we can put that little asterisk right there. And then we have this little gamma, which you can put 0, 0 if you want, but just for sake of being correct, we usually don't put the 0, 0, but the answer is just going to be the same, 227, 89, A. It's an A, C. Alright. So you can see here that the 231 protactinium released an alpha and a gamma, and it ended up as actinium with mass of 227 and a atomic number of 89. So I'm going to move to the last question right here, where I'm actually going to show you for just one thing, nitrogen 14, I'm going to show you the alpha, beta, and gamma. So let's start off with the alpha. So with the alpha, I'll put that as blue. So let's do this. Alpha. So alpha, remember, nitrogen 14, a mass of 14. If you look at the periodic table, nitrogen has a atomic number of 7. So yeah, And so it has 14, and it has 7, and we got to put nitrogen right there. We're going to do an alpha decay, so we're going to release 2 protons and 2 neutrons, so it's going to be a 4, 2 alpha. You can also put helium. And we got to figure out what we have left. So 14 minus 4, because we lose 4 from the mass, it's going to be 10. And 7 minus 2, since we lose 2 protons, it's going to be 5. So what element has 5 protons? That is boron. That's going to be boron. So this is going to be boron right here. Now let's do beta decay. For beta decay, I'll use green. So beta decay. So we're going to still start off with the nitrogen 14. So let's see right here, 14, 7 nitrogen. What's going to happen with beta decay? Remember, it's going to be a 0, -1 e. That's the release of the electron because a neutron splits into a proton electron. And so basically, this number is going to go up by 1, but this number is going to be the same because a neutron and proton are still going to have the same mass. So this is going to be 14, and it's going to be 8. And if you remember from the periodic table, the atom that has atomic number of 8 is oxygen. Just check, yep, that is oxygen. Even though most oxygens have a mass of 16, this one will just have a mass of 14. That's totally okay. Just might not be stable. So now we're going to do the gamma emission of nitrogen 14. So let me actually change this to a, now we'll make it my gamma rainbow. Alright, so gamma. Fun. Alright, so we're going to start off with this 14, 7 nitrogen. Remember gamma, you just do the little gamma sign, and if you want you can put the 0, 0 because nothing changes. Also remember, I keep forgetting this. That's the asterisk to show that it has a lot of energy. So all the energy is released in this gamma, and it's still going to be the same thing. It's just going to be a little less energetic. And that is gamma radiation. So alpha, beta, and gamma radiation of nitrogen 14.